So earlier we looked at VLANs, and we broke up our broadcast domains, and we had 3 hosts, and we had one host in VLAN 10 on switch 1, and one host in VLAN 10 on switch 2, or SW2. Yet, even though they were in the same VLANs and were in the same subnet, they couldn't communicate, right? Because the link connecting the 2 switches was only in VLAN 1, so it's only going to pass VLAN 1 traffic. Now let's look at trunks so that we can go ahead and connect those switches and pass the traffic for our VLAN 10 also. So trunks, when we configure trunk links, right? So we have access links, which is where we would connect our end devices, right? Our computers, our servers, our IP phones. We're generally going to put those things on an access, or our end devices on an access link, right? And then our other links that we have available are trunk links. And we're going to need those whenever we want to pass a VLAN to multiple switches. Okay? We'll configure trunk links for other things too. I mean, later we'll look at what we call router on a switch, or on a stick, sorry, which is where we create a trunk link between a router and a switch, so we can pass traffic for multiple VLANs and have it to the router, and have that traffic be routed by that external router. Okay, but we'll look at that later. In this instance now, we're just going to use trunk links. We're going to need them whenever we have to pass, right, a VLAN to multiple switches, which is what we're trying to do. We're trying to pass traffic from VLAN 10 on switch 1 to VLAN 10 on switch 2. Okay. By default, all the VLAN traffic we have configured, or all VLANs, are carried over the trunk link. And we'll look at how we can, if we don't want that to happen, we can prune some of those. But by default, all VLANs are carried over a trunk link. Okay. We have 2 trunking technologies that we use. ISL, okay. It's a Cisco proprietary, so if you have different vendor switches, you're obviously not going to use ISL. And even Cisco themselves in their newer switches don't have ISL as an option. Okay. And our other option is 802.1q, or referred to as .1q. That's our open standard. So, and Cisco supports 802.1q, and in all of its newer switches, or most of its newer switches, the only option is .1q as a trunk technology, sorry. And that's our open standard. So if we have multiple vendors, for sure we're going to use .1q. ISL encapsulates a frame. Okay, so it keeps that original frame, and it adds a 26-byte header and a 4-byte CRC for a total of 30 bytes added. And I think that's important to know, because you have to realize that then our MTU is going to be greater than 1500, right? Because it adds that overhead of 30 bytes. So we pay attention to that. .1q adds a 4-byte tag inside the frame. So we would kind of, in general refer to ISL as encapsulation, because it adds the 2 tags and keeps the frame. Whereas 802.1q, for all traffic coming from a VLAN, or for all tag traffic, it will add a 4-byte tag inside the frame. So we call that frame tagging. 802.1q supports quality of service, because within that tag, there are some bits available for us to signify quality of service needs. It's outside the scope of what we're doing here, but I want you to know about it. 802.1q also has the concept of a native VLAN. The native VLAN is used for all untagged frames. Okay? So any traffic that comes over or into the switch untagged, or it doesn't belong to a VLAN, so it's not tagged with a VLAN tag, will cross using the native VLAN. And that'll happen, for example, when we have an IP phone connected into the interface, and then you have a computer connected into the IP phone. The data traffic coming from through the phone and into the switch will be likely come over untagged, or we have control frames. Those will all be untagged, so any of the control frames will be untagged, and they'll use the native VLAN. When we configure our trunks, the native VLAN must match at both ends of the link. By default, the native VLAN is 1. And again, for a lot of reasons, usually security, we're not going to use that default VLAN 1. So as you see me go through things, you'll see that I change a lot of things away from VLAN 1. All right. We have the concept of dynamic trunking protocol, or DTP. Interfaces can be multiple modes. I say 4. They count no negotiate as a mode. I don't know if doesn't really make it, but hey. So we'll look at the 4 that I would specify would be access. It's an access port. It's never going to trunk, right? That's where we're going to connect our end devices to. We're not going to connect another switch to an access port. If I set the mode on the interface to trunk, that interface will be a trunk, right? It's not necessarily negotiating a trunk. That particular interface is set to become a trunk. Dynamic auto will that interface will passively become a trunk, okay? And dynamic desirable, it actively tries to be a trunk, okay? And no negotiate, although I know it's referred to as a mode, and I suppose I should call it a mode just like everyone else, but to me, it's not access, it's not trunk, it's not auto, it's not desirable. What it does is it doesn't do DTP, right? So it stops DTP frames from being generated on the interface, right? And it's a good security practice to set, if I know that my 2 links need to be trunks, or my links need to be trunks, on both interfaces on each end of the link, I'd set them to trunk and then do a no negotiate, right? So the DT frames don't even get generated, right? We don't need that traffic. We already know they're supposed to be a trunk. So, they don't need to be sending requests or to see if it needs to build a trunk there. So there are only certain interface combinations that will form a trunk. If I have at both ends of the link, both sides are trunk, it will form a trunk. If I have trunk and auto, because remember, auto passively will. Like it's kind of like a wallflower. It says, hey, if you want to dance, I'll dance. If you don't want to dance, I'm fine sitting here, right? So trunk says, yeah, I want to be a trunk. Auto says, okay, I'm fine with that, right? Trunk and desirable. I'm going to be a trunk. Desirable means I desire to be a trunk, so it'll actively seek it out. That's great because the other side's a trunk also. Desirable and auto, right? Because I'm actively seeking to be a trunk. If the other side agrees that it's willing to be a trunk and all the parameters match, for example, native VLAN, they'll become a trunk. And in this case, like I said, auto will agree to be a trunk if you want to be a trunk, right? And desirable will form a trunk because they both are actively seeking to become a trunk. If one end's access, it's not going to become a trunk. If both ends are auto, they won't become a trunk because neither side says that it wants the trunk, right? They both just kind of, reminds me of a high school dance, the girls on one side and the boys on the other side. And hey, if nobody walks to the middle to dance, they're not going to, right? And 2 interfaces in auto mode will never desire to trunk, or going along with my analogy, neither one of them will walk to the middle of the dance floor, right? So those are the interface combinations that will cause the link to form a trunk. Let's go ahead and configure it now, right? So a couple things I want to configure. I'm going to look at doing an 802.1q trunk between switch 1 and switch 2 using the dynamic trunking protocol. So it'll be like dynamic auto, dynamic desirable. And then we'll also kind of unconfigure that and do a trunk, specifying trunks at both ends and doing a no negotiate to stop the DTP frames from being created. Okay, and we're going to use the same topology that we've been using, or that we used previously. Let me erase this. Let's get rid of this guy here, right? So again, same IP addresses for my hosts, and remember, let's remember too that we're going to leave this the same. So right now this guy here is in VLAN 10. This guy here is in VLAN 10. This guy here is in VLAN 1. We're not going to do too much with him right now. Or right now these guys are in VLAN 1, but we're going to configure them as a trunk, right? So then notice how I turn that 1 into the letter T. It's pretty slick, even though I'm not the best using this to write with. Ooh, that's sort of trunk. So we'll turn, this link is here later to do a demonstration on ether channels. So we're just going to use gig 1. We're just going to turn this link right here into a trunk. That's fine. It's no big deal. Okay. So let's go ahead and do that. I'll bring switch 1 over first, and we'll do that one first. So switch 1's ready for us. Let's go ahead and configure our trunk link. Our links for gigabit 1, right? On both sides, in switch 1 and switch 2, they're connected using gig 01. So let's And we said that first we were going to use dynamic trunking protocol. So we'll do switch port, mode. Let's do dynamic desirable on this side. Just did a tab completion there. Let me get my mouse out of the way again. Switch port mode, dynamic desirable, enter. Okay. By default, the native VLAN is 1. I'm going to leave that for a minute. Let's go ahead and I'm going to do switch 2 next. So I clicked over on switch 2. Oh, he's up a little higher right now. And enable config T. Let's do dynamic desirable again. Switch port, mode, dynamic desirable. See if I can spell that. I probably should have tab completed that. All right. We'll exit out. Now they should automatically form a trunk because they should both have the same native VLAN. So let's just double check. Show int trunk. And they actually are on gig 1. Mode is desirable. That if we do a show VLAN brief, notice that our gig 01 isn't in any VLAN now, right? Trunks don't belong to VLANs. So if say you're either troubleshooting because you don't know, or you're on the exam, the cert exam, and you're trying to figure out that, they give you this show and they say, well, what can you tell me about it? Well, what I can tell you about it is if you do a show VLAN brief and that interface isn't assigned to a VLAN, then that's a trunk interface. Lastly, I just want to point out explicit trunking. Right, we're not going to use DTP. We're going to say you're going to be a trunk. We're not negotiating or making deals on either end of the link. So let's go ahead and do a config T in GI0/1, right? Switch port, mode trunk. Okay, and I did that on purpose actually because I wanted you to see it. If the switch software, right, or the iOS supports both ISL and .1Q, right? Which I suppose makes total sense why it would negotiate. This particular switch supports both ISL and .1Q, so it negotiates the Cisco proprietary, right? 2 Cisco switches, it will negotiate ISL, which makes sense. I really thought this one only had .1Q available. So then once I realized both of them were running on this code, I went ahead and just tried to tell the link that it was going to be a trunk to show you that you'll get this error or this message if the switch can run both, but you haven't specified the encapsulation type. So on this side, we didn't specify the encapsulation type, so we have to do switch port, trunk, encapsulation. We're going to use .1Q, right? Now we can do switch port, mode, gosh, there we go, trunk. Now it'll go ahead and take it. Now the other thing we want to do, remember, is we don't want to allow it to generate DTP frames. So we do switch port, mode, no negotiate. I'm going to tab, oh, no, that's not it, hold on. If you lose your thoughts for a second, the question mark is always your friend, right? So switch port, question mark, it was just no negotiate. Oh, whoops, in my window, you don't see it, do you? There we go. Now we should be, that will stop it from generating DTP frames. So sorry about that. Let's do a do show run, and let's begin at the word no negotiate. That should be in. It will, when you use the begin, it's going to start showing the output at the first instance that it sees the whatever word it is you said to begin at. And so I should only have no negotiate once. Oh, I didn't find it at all. Okay. Just use switch port as my other term. Well, apparently I just can't spell no negotiate because it's right here. I'm not going to worry about how I spelled it, but anyway. So it brought me to the first instance that it saw switch port trunk encapsulation .1Q, switch port mode trunk, no negotiate. Okay. And that would be gig 01 because 2 is right after it. So we've got our configuration the way we want it at this end. We'll go over to switch 2. I'm sorry, switch 1. And do the same thing. Switch port, trunk, encapsulation .1Q. Switch port, mode trunk, and switch port, no negotiate. And since we know I apparently can't spell no negotiate, we're going to tab complete that and hit enter. And let's do a show int trunk. Both sides should be trunking now. Forgot to check the other side before I left it. That's all right. Not going to worry about that. All right, let's go ahead and change our native VLAN because remember I said that we didn't want to use VLAN 1 really for anything. So we're going to change our native VLAN. So we're going to go back into the interface. I'm going to move my mouse again. Global config first, GI0/1. We'll do a switch port, trunk, native. Oh, I can't remember. What did we, let's say 21. I think we configured 21 on this one, correct? Spell switch port correctly. Switch port. Switch port, trunk. Native. You know, I can't remember if I have to specify. Yeah, I did. I thought so. VLAN 21. Now we should actually. Oh, actually, because we specified it, we probably won't. CDP is used to tell you or let you know that hey, you have a native VLAN mismatch, but I think because I didn't negotiate it, it's probably not going to show up. Oh, I know why it's not going to show up. So I was looking through and typing, and I realized I did have logging to the console disabled. So let's exit out, show int trunk. See, that's why I had it disabled. I probably should have. Now we should be getting a native. Oh, I know. There we go. Said to wait a minute. It was going to happen. Now that we get console logging running. Right? We now get CDP lets us know that we have a native VLAN mismatch on our link. Okay. So let's go ahead and fix that. Go back into switch 2 and do switch port. Can't seem to type today. Typing or talking. Here we go. Switch port, trunk, native VLAN. We said 21, right? Show int trunk. Okay. All right, so now our VLANs will match and our native VLANs will match and everything's good. Our trunk will be fine. It is kind of interesting. You notice that our trunk showed, you know, as available even though our native VLANs didn't match, and that's because we explicitly configured each end as trunk. There was no negotiating or checking to see if we agreed on everything. Also notice all VLANs are allowed by default. Okay. All right, let's go back to our slides and talk about a couple other things. We'll do a little more configuration. You know what we should do first is test to see that our hosts can ping each other, right? So let's go ahead and bring up host 1. Shucks, host 1. And let's ping host 3. It should work now because remember all our VLANs are passing our trunk link to get to the other side. And it does. So we're good, right? Our VLAN 10 traffic is going through switch 1, crossing our trunk link that's working because our native VLANs are matching, going into switch 2, and then switch 2 is forwarding it to host 3. So we're good to go. Now let's go ahead and look at, let's go back and some other things we can do. So this is how we look now, right? We're ready, we're good. All VLANs are being passed. If we had a bigger topology here, and let's say we had another switch up here, maybe VLAN 20 is up here, and we've got a host up here on VLAN 20, and we connect it down here, and we make that a trunk link. I probably shouldn't be drawing, I should be drawing it probably, but, right? Our switch, and we got VLAN 20 here. Not a very good drawer. Our switch there. Conceivably, and let's say that we put this on 20, okay? Conceivably, if host 2 wants to get to whoever this host is, he could go across this trunk link and then up, right? But is there any point in switch 2 getting traffic from VLAN 20 when it has nothing on VLAN 20, has no hosts on VLAN 20? What should happen is host 2 should go up through its link through this switch. We have a trunk link here, it should go this way, right? But by default, that's an S3, sort of. But by default, it's conceivable it would go across this trunk link because this one allows all VLANs by, right? This one allows all VLANs, this one allows all VLANs. We can prune, we can manually prune, or the administrator can prune VLAN 20 from this trunk link, right? Because there's no need, really, for VLAN 20 to go across this link because there's nothing on this switch that has VLAN 20 in it. So that's what we're going to do next. Let's look at how we're going to manually prune or only allow certain VLANs across the link. Okay. Again, by default, all VLANs are allowed. We think we've beaten that. We can use the command switch port trunk allow VLAN to specify particular VLANs being allowed across the link. If we specify particular VLANs and later we want to add or remove a VLAN, we use the same command except we use add or remove. Or we can do all VLANs except. So if we use the except, you can see except 20, allow all except 20. So an example, switch port trunk allow VLAN 10 and 20 means it won't allow any other VLANs except for 10 and 20 across. And then after that, if we did switch port trunk allow VLAN add 30 on that same interface, now that interface would be allowing 10, 20, and 30 and nothing else. Just make sure that you add 20. Don't think if you do switch port trunk allow VLAN 30, or I'm sorry, that you add 30. If you do switch port trunk allow VLAN 30, it will actually just overwrite the original allow command, and now only VLAN 30 is going to be allowed across that link. Okay, so go ahead and do that, and then we'll be done with the trunking section. Now here we don't actually have that third switch that I talked about, that reason why you would only want to allow and you want to administratively or manually prune those VLANs. We're just going to configure it here as in our example. So let's do a show int, whoops, clicking on the wrong spot here. Let's do a show int trunk, for show interfaces trunk. And we see that all VLANs are allowed 1 to 4094. So let's go into gig 01 and let's just allow VLAN 10. Okay. Whoops. Don't forget the interfaces command. Switch port trunk allow my mouse VLAN, which can allow 10, right? Switch port trunk allow VLAN 10. Let's show. I'm going to get rid of this console logging again. You know what? I should leave it there for a second. Show in trunk. Now you'll notice that the only VLAN being allowed is 10. And that's it. Let's go ahead and big T. Let's add VLAN 1. Oops. Switch port, trunk, allow, add. Whoops, no, I did. Switch port, trunk. It's probably just add. VLAN, what do we say, 1? All right, good old fashioned, having a brain fart here, good old fashioned. Oh, I know what the problem is, I can't spell. Switch port. Wow. Yeah, allowed. Wow. Now it should be add, and we're going to add VLAN 1. Okay. Add 1. It's funny, I can write them all down, and then you go to do it. And I've done it a ton of times for whatever reason. Thank goodness for the question mark. I don't know why I just had a brain fart there. So switch port, trunk, allowed, VLAN, add 1. Now if we do a show int trunk, we should see 1 and 10. Let's do one more thing, just because, right? Let's do all except. Let's see if I can remember the command, even though we just got done doing it. And I've probably done it 100 times this week. Switch port, trunk, allowed, VLAN, except. Let's do except 25. Right? So now we should be allowing everything except for 25. Do show int trunk. Okay, and it does. So we allowing VLANs 1 to 24 and then 26 to 4094. So I think that's it. You've seen trunking and manual pruning. That's it.